Now, once we've calculated these relative percent differences, it's just not an exercise in futility. We are actually going to use this data. We're going to take them to our control charts. And the control charts that you can see, there are two of them. One is for where both measurements are greater than or equal to 4 picocuries per liter. And the other graph is where both measurements are less than 4 picocuries per liter. Now, if you look how these are graphed, we calculate the relative percent difference and then we plot them on the graph. The horizontal axis is just recording the day. If you're doing 2, 3, 5 measurements in a day, just put them next to each other. It's not important what order they go in. And what we're looking at is to see how reliable our data is and how consistently we're getting good results. We expect that 90% of our data will be below the 1 standard deviation line, which varies depending upon which graph you're on. When duplicate measurements are 4 or greater, then 1, 2, and 3 standard deviations is 14, 28, and 36. We expect them to be less than 36% relative percent difference, which, if you recall from the simultaneous method, is where we expect to see most of our data. But if you also see, that's just another way of saying that we do expect 1% of the data to be outside that 36% relative percent difference. Now, if we move over to the less than 4 chart, we're looking at the 1, 2, and 3 standard deviations as different numbers. The statisticians have calculated that for us, and we expect a 67% relative percent difference or less. Where does this error come from, though? Are we making all kinds of mistakes consistently to cause it? Well, no, not necessarily. It comes from the nature of the radioactive decay, which not just of radon, of any material. If you remember the half-life chart, that was a trend graph. What's really going on at any one point in time, radioactive decay is quite random. So if you look at the random error graph that we have here, you can see that it's common to count over 10-minute periods of time, and it can be fairly easy to count over a period of time, about 1% of the time, when you're not counting what's representative of the entire period of time. So 10-minute counts 99% of the time gives us the right number. 1% of the time it won't.